Fermat's. What if I put on the test who is responsible for Fermat's last theorem? Oh, I was going to say Fermat, but for disproving it would be Euler. One time in Algebra 2, I don't know if Mr. McClure still gives the same test that I gave, but an actual question on the test, not bonus, was who discovered Cramer's rule. I don't even know if you do that anymore. And people would get so mad. I can't believe we're supposed to know this. And it's just Cramer. Cramer's rule is Cramer. But people missed it every time. Okay, so part of your homework today isn't terrible because it's just learning how to do this k plus 1 thing. So let's practice one of those before we get to the actual proof. Because when we do these proofs, we have to substitute in k plus 1 for k to do the kth term and the k plus 1 term. Sorry, trying to move my phone. So if this is p sub k, this is a formula for p sub k, what do you think I'm going to do to find p sub k plus 1? What? Add 1 to everywhere that you see a k is going to change to k plus 1. Just like if f of x equals x squared plus 3x, and I asked you to do f of x plus 1, right? Wouldn't you go through and everywhere you saw an x, you'd replace it with x plus 1? Same idea with the k plus 1 term. Everywhere I see a k, I'm going to replace it with k plus 1. So k squared is going to become k plus 1 squared. And I'm going to show my work on this, but I'm okay if you just do this in your head. But this k is going to be k plus 1, but there's still that plus 1 there, which is really just k plus 2 all over 4. There is no expectation that you FOIL that out, but I would say you should say that's k plus 2. Like I would write this as k plus 1 squared times k plus 2 squared all over 4. That is my k plus 1 term. And I believe there are some questions somewhere on your homework that you're just doing like the kth term and the k plus 1 term. But the rest of it is proof. So let's look at one of these proofs. I'm going to take it pretty slow here, and then I'm hoping that we can fit in a second one so you can see that it's the same every time, just the numbers change. This is very much a proof, which means you can't skip steps. You have to show me the work. That's what a proof is. If you don't show me the work, then it's not a true proof, and you're not going to get all your points when we do this. All right? So let's just jump in here. Use math induction to prove. And all of these are just going to be a sequence, and there's going to be a formula for the nth term, and there's going to be a formula for the sum. Bryce, don't fall asleep now. It's an important day. So here's the sequence. 3 plus 7 plus 11 plus 15, and then dot, dot, dot. Any nth term could be written as 4n minus 1. And you can check. The fourth term, 4 times 4 minus 1. Yeah, that works. And then this is this formula for the sum. It says if you add up the sum of the nth terms, so whether you're adding up the first 4 terms, the first 12 terms, the first 100 terms, then this is the formula that they're giving us. We want to prove that that's true. You cannot prove by just checking the first 2 or 3 terms. That does not prove it. That's why we have to go to this whole k thing. All right? Step 1 is the easy step. Step 1, prove for p sub 1. Which means we're just going to prove that it works for the first term. And if I look at when n is 1, all I'm going to do is plug in 1 in for both of those and show that it equals the same thing. It should always work. So I'm going to say 4 times 1 minus 1 equals 1. times 1 plus 1. It's a proof, so show me some work there, right? Like I just always plug it in and then I write the answer. If you want to do a little bit of work as you go, I'm okay with that. But show me that you know to plug 1 into both sides of that formula. And when I plug 1 in there, I get that the first term is 3. The first term is 3. And if I do 1 on this side, I get 2 plus 1 is 3 times 1. 3 equals 3, which means I just did step 1. It worked for the first number. With me so far? That's the easy part. The second part, we need to prove that this is true for the k plus 1 term. And again, every time these are steps that you need to show. So step 1 is we don't even have a k term right now. So we can't do k plus 1 if we don't have p sub k. Right now we have p sub n. So we're going to say, and I know people really struggle with this, but we're going to say, let's assume that p sub k is true. And I know what they say about assuming. I'm aware of the statement. But in proof by deduction, we say, let's assume that p sub k is true. If p sub k is true, we're going to prove the k plus 1 term. P sub k is true. So, if this is p sub n, what do you think I'm going to do to change that to p sub k? Can I just change all my n's to k's? Are you with me on that? And people think this is a silly step, but it's kind of important for later on in the proof. It's also important because n represents the nth term. K is some number in between that, right? Like nth is like the ending term, the nth term. K is some number in between 1 and n, whatever n happens to be. So that's why we change it to k. So I'm going to go through, and all I'm going to do is I'm going to change my n's to k's. So now this is going to say for k minus 1, and the sum of the first k terms would be k times 2k plus 1. All I've done is change this line to k's. Ideally, what we're trying to do is do the next term. If we do the k plus 1 term, we want to show that when we do k plus 1 on this side, it equals the same thing when we do k plus 1 on this side. I struggle fitting all that on one line of paper, especially fitting that all on the smartboard here. So on your homework, if you do this all in one line, I'm okay with it. But I can't fit it all in one line, so I always break it up into 2 parts. I'm going to do this part first, and then I'm going to go back and prove this part. But both of them, I want to do the k plus 1 term. All right, so I'm going to do this twice. Step 1 is I want to know what would the sum of the k plus 1 term be, kind of like what we just did. So everywhere I see a k, I'm just going to change it to k plus 1. And I'm going to work that out, but I just want you to see that I'm just replacing k with k plus 1. If you show a little bit, like don't show that step, I'm okay with it, as long as you get your math done right. So all I'm doing is if this is the k sum, the k plus 1 sum would be plugging that in, and I would get k plus 1 times 2k plus 2 plus 1. You agree that that would be 2k plus 3? And then we're going to see that sometimes you have to work this out and sometimes you don't. So it's kind of up to you if you go ahead and work it out. But I'm going to go ahead and work this one out. And then we can come back later and see if we needed to. But I'm going to FOIL that out. And I hope that at this point in your life of precalculus that you can kind of do that in your head a little bit. This is 2k squared. This is 3k plus 2k. So that's going to be 5k. And then 1 times 3 is 3. This is the sum of the k plus 1 term. I want to get the same thing when I go back over here and do the k plus 1 term. So I like to kind of, at least in your notes, kind of underline this and say this is what you want to get. So I'm going to say this is my end result. It's kind of like you get your answer before you go and do the other proof. so you know what you want to happen. Yes. Because if I distribute this, I get 2k plus 2, right? 2 plus 1 is 3. Other questions to this point? So that's my end part. Now I got to go back and do the same thing over here. So now I always go back. And now I'm going to do the same thing for this part. So now I'm going to also say k plus 1. But instead of talking about the sum, I'm talking about the pattern. And if I'm talking about the pattern, let's think about it not in terms of k for a minute. If I want you to write out the first 6 terms, do you agree you have to write out 1, 2, 3, 4, 5 before you can do the 6th one? So the same thing on here. If I want you to write out the p sub k plus 1 term, you got to write everything out. You got to write 3 plus 7 plus 11 plus 15 plus dot 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 plus 4k minus 1. That's the k terms plus the next term. So when you're writing the pattern out, you have to write all the old stuff out plus the next term. So the next term would be plugging in k plus 1. And if it helps, kind of circle all this. All of that is p sub k. And then you're adding the next term to that. Right? If you knew the first 5 terms, you could just write out the first 5 terms and then add the 6th term. We're just calling that the k term and the k plus 1. It's exciting, right? Because that's in the original problem, right? That's the nth term or that's the kth term. So I wrote this whole thing out and then I just added the next term. So every time, whatever your k is, you're going to write all of that and then plus the next one. Does that make sense? And then could I say that's the same as saying just p sub k, which is all this, plus the next term, which is 4k plus 1 minus 1. So here's the big proof thing. Other than this, it's just kind of step by step. It's kind of weird at first because you haven't done it before. But once you do a few of these, it's the same every time. But here's the step that you got to know. Do I know what p sub k adds up to? Scroll back up. Let's go up here. P sub k, do I know what it adds up to? Is that the sum of p sub k? Every time. It's why we write this first step out, is we know that p sub k is supposed to add up to this. It's why we assume that it's true. So if this, let's write this here, the sum of p sub k, you can plug that in for p sub k. We know that that adds up to p sub k. So I can replace p sub k with k times 2k plus 1, because that's what it adds up to. I'm going to go ahead and distribute that 4. And what we should be able to do now is simplify this and get the same thing of what we wanted to get up there, our end result. If it doesn't happen, then you've done something wrong, because these always work, which is why the steps are so important, because I know what you did in geometry. You wrote your givens, you wrote your end statement, and you just made stuff up in the middle and hope the teacher didn't notice, right? I'm on to you. The middle stuff matters. That's the steps I'm going to be checking, because this should work every time. So this would be 2k squared plus k plus 4k plus 3, or that's 2k squared plus 5k plus 3. The question is, does this, which I've written so big on here, I don't even think I can, does this match what I wanted to get up there? See how those equal the same thing? We've just proven that when you sequence. So what I like to do is I draw a little line to show those equal the same thing, and then I put a little check mark. Or you can put a little smiley face. Or you can write proven. Or there's some math notation, I always forget which way it is. Like this, or maybe it's like this. One of them means like proven. My foreign exchange students always do that, and I always forget which one it is, but because they do that in the other countries apparently. I just put a check. Yeah, this is exciting stuff, right? Let's do another one. Oh wait, hold on. I want to show you this. This is very abstract, and so one time at a math conference, someone talked about proof by induction, and someone gave an example to try to make it a little bit more concrete. Because talking about k plus 1 terms and k terms, people really struggle with. And I know when I show you this example, some of you are going to be like, well, that's stupid, you can't really do this. But it's trying to make you think about what we're doing. So if I wanted to prove to you that I could climb a ladder that goes on forever, right, that's kind of like this. I want to prove to you that when you add something up that goes on forever, if I want to prove to you that I can climb a ladder that goes on forever, I could go through these steps. So I'm going to kind of read through this with you. So this is not really required to know, but it's just trying to make this make sense. It says, in order to prove that I can climb a ladder with infinite rungs, I could do the following. First, I will show you that I can get on a ladder. That's like the first step. Prove that it's true for one. If I can prove to you that I can climb on the first step, that's going to be something to show you that I can climb a ladder. Second of all, if I can show you that I'm on any rung of the ladder, that would be the kth term. If I'm on any term, whether it's the 12th rung of the ladder or the 100th rung of the ladder, if I can prove to you that I can go from one rung to the other, do you agree that that means I could climb the whole ladder? I know you would die before you got to the top of an infinite ladder. I'm with you on that. But theoretically speaking, if I can prove to you I can get on the ladder, and I prove to you that if I'm on any rung of the ladder, I can get to the next rung, that's what proof by induction is. So you prove that it works first, and you prove that no matter where you are, the kth term, you prove that the next term also works. That is a proof showing that it works for every number. Nothing? I thought it made sense, but yes.
So on that last example, do we just plug in k plus 1 k out both of those equations?
Kind of. On this one, we plugged in k plus 1 to get this, but we wrote the whole equation there also. You see what I'm saying? Like, we wrote the original part plus k plus 1. Yes, no, maybe? We're going to do another one. So I feel like the first one's really rough, and the second one you see that it's the same idea and it doesn't get so bad. I feel like it sort of makes it a little more concrete. I know it's kind of weird to think about an infinite ladder, but it at least makes you at least understand what this k is. So I can tell you when I did in Math 380 in college, we did proof by induction, and I just remember my professor, who was like this tall, she would always say, let's assume, and she would write it on the board in cursive, which is how I write it because I can't stop myself. And it was really weird, and I never understood this whole k plus 1. I did it because it's the same every time, but I thought this made it make a little bit more sense. So you don't have to write it all down, but I can give you this back later. I don't really want you to write all this down. But let's see if we can look at one more and get through it so that you can see the idea here. This is not going to be a huge part of your test, but there is going to be a proof by induction. It's probably 8 to 10 points. It's a decent chunk of a test. So you want to at least have some idea what you're doing. Yes? And I'll come back to this for you in a minute, Taylor, if you need more of it. Let's look at this one. It's exciting. It has fractions in it. Same direction. Prove. I'm going to show you how I write these out on my paper. And yes, it's important that you write lots of steps when you do this. Don't jump around. Because it's not a proof. Skip steps. The proof part is showing it. Wait till we get to next semester, we get to do trigonometric proofs. We're so excited. I was so scared I was going to have my baby right before trig proofs, and then my sub would have to teach it, and I was scared, but I didn't. I taught it before I did. Every time they're going to give you a pattern, they're going to give you the first few terms, they're going to give you the formula for the nth term, they're going to give you the formula for the sum. And then every time you're going to do the same thing. Step 1, and I really number it, but you don't have to, but you do need to say you're going to prove that P sub 1 is true. And you're just going to plug 1 into that formula, and you're going to show that it is true. So I'm going to say that 1 plus 1 over 1 equals 1 plus 1. 2 equals 2. Hooray, I got some points on my test. Everybody with me on that step? And then every time, step 2, we're going to say, let's assume that P sub k is true. And yes, you have to write that. And then I'm going to write out what P sub k is. And sometimes you can get a little lazy and not write the whole thing. Like on this one, I'm just going to say 1 plus 1 over 1 times 1 plus 1 over 2. And then I'm going to go ahead and say dot, dot, dot. I think I'll leave 1 out. 1 plus 1 over k equals k plus 1. And then what we want to do is we want to do the k plus term on both sides of this. And if you want, I can try to squish this all in one line of paper. I just really struggle sometimes. But we want to do the k plus 1 term on this side. We want to do the k plus 1 term on this side. And we want to show that they equal the same thing. So you tell me what you want to do. Do you want me to separate it like I did on the last one? That's how I always do it. Or do you want me to try to squish it all in one line? No thing. I'll just do what I want to do. I'm going to do it my way then. I'm going to start over here. So I'm going to say the k plus 1 term, the answer that I want to get at the end of this is k plus 1 plus 1 or k plus 2. You with me on that? All I did was replace k with k plus 1. K plus 1 plus 1 is k plus 2. Nothing on that side yet, just on this side. Other questions on where I'm getting that from? Every time, that's what you want. That means when we do the other part, we better get k plus 2 as our answer or we've done something wrong. So that's kind of the nice part is you know what's supposed to happen. The other nice part is it's exactly the same every time. So when I come back over here, I'm going to say that my k plus 1 term is all of this, 1 plus 1 over 1 times 1 plus 1 over 2, dot, 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 times 1 plus 1 over k. Right? I haven't changed anything. But what would the next term be? I just take this and I replace k with k plus 1. And every time it works out the same way. This is all p sub k. So the next line on my paper always says that that is p sub k times 1 plus 1 over k plus 1. Because it's all that before times my next term, or plus, depending on the problem. And every single time, do we know what p sub k adds up to? P sub k, that's p sub k plus 1. P sub k is what we wrote out first. Go all the way down. Do we know what p sub k adds up to? It adds up to k plus 1. So I can replace this with k plus 1. And all that's left is the algebra to make that work out. So you plug in the k plus 1 over there. You come back over here. P sub k times your k plus 1 term. Plug it in. And then you just have to work it out. And this one's kind of hard because you have a fraction in here. Can I get a common denominator between these two? Agree that this would just be k plus 1 over k plus 1. So if I got a common denominator here, this would become k plus 1 and then plus 1 all over my common denominator. I'm trying to avoid going up too far so that I can draw a line. And what's super great is we're multiplying. So if we're multiplying, can I cross out this k plus 1 with this k plus 1? What am I left with? K plus 2. Is that what I was supposed to get? Which means I can say, hooray! I did it right. It's kind of weird, but it's kind of very much step by step. If you took really good notes today, you should be able to do the ones on your homework. We will definitely look at some tomorrow on your homework. There's more to this lesson. I have it on your assignment sheets. Do it all in one day, but I don't know why I always think that I can do it because we spend the whole day just doing proofs. Tomorrow's part of the lesson isn't so bad, so we'll have time to talk about some of these. But I cannot emphasize enough that if you don't try these, by the time we get to the test, you're going to have no clue what you're doing. So you have to at least attempt these. If you get stuck, we can look to see where you're getting stuck at. This is different than your assignment sheet. We're going to call this 9-6 day 1. And you're just going to do 1, 4, 10, 15, 37, and 38. And then tomorrow, we will look at the rest of it. Try them, all right? There's a lot of proofs. There's one on here that's kind of tricky, really tricky, but 1's not so bad. 4's not so bad. I think, I don't know which one's so bad, but definitely this will be on our test. So the test is planned for Friday, so you need to make sure that you're caught up on your homework. This is our last test. It's our last big homework. Definitely could help your